Good morning, my dear students. My name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. So, in last class we discussed the definition terminology on types of heat exchangers mainly. We'll continue this one. Definition terminology of heat exchanging methods. So, different methods are there. We saw LMTD for designing of heat exchanger and NTU methods. We'll see what are the different terminologies which are included in the these type of methods. So before going to that, we'll see what is the fouling factor. This is very important factor in heat exchangers because heat exchanger is the just a passing of fluids in the pipes to transfer the heat from hot fluid to cold fluid. You know this one. Okay. So when the fluid flows in the pipes will be reacted due to that fluid. Some type of scales or sledges forms on the uh, surface of the fluids, inner surface of the fluids. Okay. So due to this one, some heat transfer rate will be decreased. It means so, coefficient heat transfer will be decreased. Overall heat transfer coefficient will be uh, changed. Okay. So for this one, just you have to consider the fouling factors. We'll see what is fouling factor. Okay, surface of the heat exchanger do not remain clean after it has been in use for some time. Okay. So when they are using, they do not remain clean because when the fluid is flowing through pipes, there may be some reaction between the fluids and the pipes, and some type of sludges and some type of scales will be formed on the surface of the pipes. Okay. The surfaces become foul with scaling and deposits which are formed due to impurities in the fluid. Okay. So the chemical reaction between the fluid and material, due to the chemical reactions which are impurities, uh, due to the chemical reaction between the impurities of the fluid and the um, pipe material. Okay. So due to this reason, some types of scaling, some types of sledges are formed on the surfaces. So due to the scaling, automatically heat transfer rate will be decreases. Okay. So it means so the scaling affect the overall heat transfer coefficient. Okay. So the effect of these deposits affecting the value of overall heat transfer coefficient. This effect is taken by introducing an additional thermal resistance. So this effect we have to consider this one. So for this one, we have to add the additional thermal resistance, that is called the fouling resistance. We have to add the fouling resistance for finding the rate of heat transfer. This represented by R of fouling resistance should be added to the um, overall heat transfer coefficient. Okay. We'll see here some formulas how to add the uh, following factors. So this one is the overall heat transfer coefficient with respect to outer surface. This is the overall heat transfer coefficient with respect to inner surface. Okay. So just like the flow is flowing through between the two uh, pipes, aeronautical pipes. Suppose flow is flowing this pipe, outer surface is something like this. So this is the RI, this is the R naught. Okay. You'll see length of the pipe also. That is the length. So here just you can add base with respect to outer surface. You have to find out the overall heat transfer coefficient. With respect to inner surface, you can find out the overall heat transfer coefficient. With respect to outer surface means that is exposed to atmosphere, automatically some scaling or some formations, deposits formed on the surface of that one. Here also in inner surface, due to the flowing of fluids, the impurities which are in the fluids react with the surface and forms on the surfaces. So here, so this is the inner surface means RF naught F5, that is the uh, resistance of the fouling factor. R F naught is the outer surface resistance fouling factor. You have to add this one. Here 1 by H naught into R F naught play. So R naught by K, the thermal conductivity, ln R naught by Ri. So R naught Ri, you know this one, inner diameter, inner radius and outer radius. So in this way, how to add the fouling factor to find the uh, exact, it means to find the real rate of heat transfer rate in that heat exchangers. Okay. So you have to consider the fouling factor for finding the rate of heat transfer based upon this fouling reactions. It means uh, chemical reactions. Now we'll see LMTD method. What is meant by LMTD? What is the importance of LMTD? To design the heat exchangers, there are many types of heat exchangers. We already discussed in a previous class. To design these heat exchangers, mainly parallel fluid exchanger, counter fluid exchanger, and cross fluid exchanger, there are two methods are there. One is the LMTD method. To find out the rate of heat transfer in the parallel flow, counter flow, cross flow, we'll use the methods, two methods. One is the LMTD method, another one is the NTU method. So first of all, we'll see LMTD method. What is the importance of LMTD method? It is called log mean temperature difference. LMTD is the driving force for the amount of heat exchanged heat by a heat exchanger. So LMTD delta TLM is the approach is quite straightforward and simple. So, but this approach cannot be used for the cases where the phase changes occurs in the heat exchangers. Only uh, unphase changed heat exchangers means parallel flow, counter flow, cross flow. We'll see. Okay. The total heat transfer rate mainly. Uh, if you see the graph, this is the hot fluid inlet to cold fluid outlet. Hot fluid outlet, cold fluid inlet to cold fluid inlet to, this one is the cold fluid outlet heat transfer. Every time the graph is like this one, every point to the rate of heat transfer values will be varying. Okay. To find the values, to consider these values and finding the rate of heat transfer, just we will use the logarithmic principles. So for this one, so that is the method that is related to logarithmic. The method is called LMTT method. Okay. So according to LMTT method, Q is equal to UA into delta T LM. Delta T LM, the formula, you know this one. Delta T LM is equal to delta T1 minus delta T2 by LM into ln into not LM, ln delta T1 by delta T2. Okay. You know that delta T1 is the these temperature differences. So delta T2, these temperature differences. So delta T1 and delta T2 are different for the parallel flow and counter flow. So by using this LMTD method, we can find out the rate of heat transfer for the any heat type of heat exchanger, either parallel flow, counter flow, or cross flow also. Okay. You know that the Q is the heat transfer in the heat exchangers, rate of heat transfer. U is the overall heat transfer coefficient. Next, area is the heat transfer area. You can see. Okay. So this is the formula uh, for finding the rate of heat transfer in a heat exchangers. You know this one. So already the final formula is like this one. You know this rate of heat transfer Q is equal to UA into delta TLM. Delta TLM is equal to delta T1 minus delta T2 by ln of delta T1 by delta T2. So this is the formula. So delta T1 for parallel flow both in inlet to temperatures THA minus TCA. Delta T2 outlet temperature differences TH0 minus TC0. So, so the finally QA is equal to QE is equal to UA into delta TL T1 minus delta T2 by ln of delta T1 by delta T2. This is the formula. Okay. Delta T1, delta T2 values will be changed based upon the type of heat exchanger. For the parallel flow, these are the values. For the counter flow, delta T1 is equal to THA minus TC0. Delta T2 is equal to TH0 minus TCA. Okay. Inlet and outlet is different. Okay. So by using this one, we can find out the rate of heat transfer value, heat exchange value in that exchanger, heat exchangers. Okay. You can see. So now we'll see NTU method. What is the importance of NTU method? We have already LMTD method for design of heat exchanger or finding the rate of heat transfer. But why how to go for the NTU method? What is the importance of NTU method? In LMTD method, we saw already formula, that is Q is equal to UA into delta T Ln. Delta TLN means UA into delta T1 minus delta T2 by ln of delta T1 by delta T2. Okay. But here you know that for the parallel flow, delta T1 is equal to THA minus TCA. Delta T2 is equal to TH0 minus TC0. Okay. For the parallel flow means for the counter flow, delta T1 is equal to TH0 THA minus TC0. Delta T2 is equal to TH0 minus TCA. TC. These are the values. In the both cases, we are observing here four temperature parameters: inlet and outlet temperature of cold fluid, inlet and outlet temperature of the hot fluid. So by using these four temperatures of cold fluid and hot fluid, you can find out the heat exchange value, rate of heat transfer, or heat flux. Okay. So in that heat exchanger, so this is LMTD method. Suppose in some cases, uh, if the outlet temperatures of the both fluids are not given, it means only inlet temperatures we know THA and TC0, TCA. It means we know only inlet temperatures of the both the fluids. We don't know the outlet temperatures of the both the fluids, because outlet is attached to the another thing. Sometimes we unable to find the outlet values of hot fluid and cold fluid. Okay. So in those cases, we can't use the LMTD method to find the rate of heat transfer. Okay. So in that case, in that case, we'll prefer the NTU method. By using NTU method, we can find the rate of heat transfer without the use of outlet temperatures of the both the fluids. Both the fluids means hot fluid and cold fluid. Okay. So that is the main advantage of NTU method. NTU method, that is nothing but number of transfer units NTU is used to calculate the rate of heat transfer in heat exchanger. In heat exchanger. So especially counter current heat exchangers, when there is insufficient information to calculate the logarithmic mean. Insufficient information means we know only inlet temperatures of both the fluids. We don't know the outlet temperatures of the both fluid. In that case, it means if you know the inlet temperatures, then by the help of NTU method, we can find out the rate of heat transfer. Okay. So NTU is nothing but UA by C minimum. UA, U overall heat transfer coefficient, A is the area of the fluid flow, C minimum specific heat minimum means, so this is the formula. C minimum is equal to where only inlet temperatures are there. It means Q is equal to C minimum into delta T means, you know this one. If the delta T mean is greater high value, this is the greater value, it should be minimum. It means greater, when will we will see the greater value, it means the heat transfer rate delta T is equal to high temperature of the hot fluid minus low temperature of the cold fluid. So the difference of this one is the maximum delta T. Delta T max. Temperature difference, maximum temperature difference. So when the maximum temperature difference is multiplied with the specific heat, that specific heat is nothing but C minimum. Okay. So here you can see Q max, maximum possible heat transfer is equal to C minimum to uh, inlet temperature differences of both the fluids. Okay, we'll see one by one thing. What is the formula used in the NTU method to find the rate of heat transfer also? We'll see. So this is the alternate method for the heat exchanger instead of LMTD. It is called effective NTU method. You can see NTU stand for the number of transfer units. You know this one. Origin of this method is based on the fact that in practice, outlet temperature of the fluid streams from the heat exchanger may not be available due to heat exchanger being connected to a downstream processing unit, such as in reactors, chillers. We'll see outlet terminals are connected to downstream processing units. So due to that one, we are unable to take the uh, readings of outlet temperature of the fluid. In those cases, we will use this NTU method to design and to find the rate of heat transfer. Okay. It means in some cases, only out of 4 temperatures, only we have 2 temperatures. It means inlet temperatures especially. So in that case, we will use this NTU method. Okay. So for these cases, LMTD is not suitable. For solving the rate of heat transfer by LMTD, we require the 4 temperatures, inlet and outlet temperature of both the fluids. Okay. If you have only inlet temperatures of both the fluids, you can prefer the NTU method. Okay. This is the formulas for NTU method to find the effectiveness or the rate of heat transfer. So we'll see what is effectiveness. Effectiveness is defined as the ratio of actual heat transfer rate to maximum possible heat transfer. Maximum possible heat transfer means heat transfer takes place highest temperature HI minus so lowest temperature cold fluid TCE. Okay. So this the difference is the maximum heat transfer rate. Okay. So at that specific heat is the C minimum, that is called Q max. So effectiveness is equal to actual heat transfer by maximum possible of heat transfer. Actual heat transfer is the Q. Maximum possible heat transfer is equal to Q max. That is nothing but effectiveness. By finding effectiveness, you can find out the Q value, because for Q is equal to effectiveness. If you know the effectiveness, and you can multiply this one Q max. Q max is nothing but C minimum into THI minus TC. Okay. So C minimum you can will be given, and THA and TCA inlet temperatures will be given. You can find out the Q max by the help of then you have to find out the effectiveness by the help of NTU method. Then you can find out the rate of heat transfer in that heat exchanger. So that is the formula. So now we'll see how to find out the effectiveness. What is the formula to find out the effectiveness? This is the formula to find out the effectiveness by NTU method. Okay. So this is for parallel fluid exchanger. So counter fluid is different. Okay. So 1 minus exponential of minus NTU into 1 plus C minimum by C max. 1 plus C minimum by C max. C minimum means so C is nothing but CH into MH. You know this. Hot fluid mass into specific heat for the CH, for the CC. Cold fluid specific heat into mass of the cold fluid. You know this formula. So these values will be given. Then you can find out the CH, the hot fluid specific heat, and cold fluid specific. Then you can find compare this one, which is minimum. So you can that will be the C minimum, which is maximum. That will be the C max. So sometimes CH is the C minimum, sometimes CC is the C minimum. So based upon the values will be provided in the numerator. Okay. So epsilon is equal to 1 minus exponential of minus NT into 1 plus C minimum by C maximum. You can rewrite like this one, 1 minus exponential of NTU, you can represent this one N into 1 plus C minimum by C max, you can represent this one C divided by 1 plus C. Shortcut value, okay, like this. Like this. So effectiveness epsilon is equal to 1 minus exponential minus N. N is nothing but NTU plus 1 by C. C is nothing but a C minimum by C max by 1 plus C. This is the formula for finding the effectiveness through NTU method in parallel fluid exchanger mainly. Okay. For counter fluid exchanger is different formula. We'll see that one also. If you know the effectiveness, then you can find out, and if you know the Q max is equal to C minimum into inlet temperature will be given. Okay. So then you can find out rate of heat transfer. Q is equal to Q max into epsilon effectiveness. Okay. So in this way, you can find out the rate of heat transfer through NTU method in parallel flow or counter flow and cross flow. Okay. So what advantage does effectiveness NTU method have other than the LMTD method? You already discussed this one. So LMTD method has some drawback. For finding the rate of heat transfer by using the LMTD method, we require the 4 temperatures: hot fluid inlet to hot fluid outlet to cold fluid inlet to cold fluid outlet. Should require, must require these four temperatures. Okay. So some cases outlet temperature will not be provided because outlet terminals are attached to the another processing system in some heat exchanger designs. Only input temperatures will be marked, will be taken. Okay. In those cases, effectiveness LMTD method is not possible or not suitable or not useful to find the rate of heat transfer. In those cases, it means only inlet temperatures are given, then you can find out the rate of heat transfer of any heat exchanger by using NTU method. Okay. So that is the, so these are the some reference books are given. You can refer this one. Thank you for listening this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.